Good afternoon. My name is Vladyslav Kholiev. Today I represent Kharkiv National University of Radio Electronics. The presentation is devoted to one of the possible approaches to accelerate term weight sorting in the frequency dictionary, and the title is Information Object Storage Model with Accelerated Text Processing Methods. This approach allows to more quickly improve the efficiency of the storage of information objects. The content of my presentation can be expressed in the following points. It starts from introduction, including motivation, analysis of related works and main goals. Then I present the proposed organization model of scientific work electronic storage, as well as main steps of text processing on the information accumulation stage of this model. Then we will focus on the assessment of the frequency dictionary sorting time in serial and parallel implementation on shared memory and on massively parallel computational systems. Lastly, the presentation ends with conclusion. There exists a problem of constant increase of the information amount, which in turn leads to the increase of the required speed of search engines and information categorizing systems, which are based on some of the methods presented on the slide, as well as the ever-increasing complexity of information object storage organization at the stages of information accumulation and access to said information. The slide shows that methods such as text vectorization are significant in different areas and different tasks, which determines the high relevance of the analysis and improvement of these methods. Thus, the representation of text in the form of vectors can be considered one of the main steps of text preprocessing, as it allows to consider text not as a set of tokens or symbols, but in a more computer-friendly way, in the form of a vector. This approach is a basic tool in the field of text mining, information retrieval, classification and clustering of text documents. Modern research papers confirm the relevance of the text proximity detection problem, which is also based on the text vectorization and the construction of frequency dictionary, due to the widespread use of this task in plagiarism detection, determining document authorship, information retrieval, machine translation, tests and tasks creation, automatic construction of text abstract, etc. Many researchers confirm the effectiveness of TF-IDF model usage for determining term weights in the text summarization and sentence similarity tasks on the basis of the word frequency and inverse document frequency. Among the most significant practical solutions relevant to the information object storing and processing are electronic libraries, plagiarism detection services, electronic vocabularies, biometrical systems, and so on. The goal of the work is to create an information object storage model with accelerated text processing methods. To achieve this goal, the following tasks must be solved: development of an information object storage model, the analysis of preprocessing methods to identify the possibility of implementation of mass parallelism systems, research of the influence of computer system characteristics on the implementation of a modified methods for determining the weight of words in the text corpus, and finally the analysis of obtained results. To provide fast and relevant access to information object, the organizational model of electronic I/O storage was proposed. As shown on the slide, organization of storage can be divided into two stages: information accumulation and access. The operation of each stage consists of the operation of individual algorithms. The proposed model consists of the following modules: the module for preprocessing search query, information search image module, the module for searching the keyword in the corpus, and database creation module. The input of the model receives a large number of documents in different formats such as TXT, doc, PDF, etc. Then the model selects the code library depending on the document format and extracts data, namely keywords, from the document in the form of updated text. The selected keywords are then used as input values at the stage of classification and cataloger construction. An important stage of the algorithm is that the previous classification stage is the filtering of the text through the stop words list, short words and punctuation marks that do not carry any semantic load for the further analysis. This reduces the volume of the text and increases the semantic value overall. The most important problem at the stage of catalog formation is the categorization of new documents with high accuracy. It is a complex task with a great number of pre-processing steps which have a great influence on the categorization accuracy. The sequence of pre-processing methods includes a different level of analysis: grapheme level, selection of tokens which are individual words in the text; morphological level, definition of grammatical forms and categories of words; and lastly, syntactic level. The results of such text pre-processing algorithm are shown on the slide. The work also proposes a classification of documents based on the frequency dictionary, the input of which is the aforementioned pre-processed text. To build the frequency dictionary, it is necessary to determine the IDF measure. By default, the result of the TF-IDF model is a dictionary with the weights of each word. The key in this case will be the words that have an IDF measure in the middle range of the values, because for the words that occur in the large number of documents, IDF will be close to 0, and strictly 0 for the words that occur in all of them, which indicates the semantic importance of the word. The lowest IDF is for commonly used words, and highest for the words that are unique to each document. The time to construct an ordered frequency dictionary depends on the size of the collection. Arranging the IDF values of the large number of terms is a time-consuming operation, as a sequential algorithm is used by default. The work conducts an experimental study on the effect of using different sorting algorithms for keyword selection time in accordance to the sorted IDF values. The results of the keyword selection for different sized collection with standard sorting of IDF values are currently shown on the slide. As it shows, the sorting time for the defined weights of the terms for large dictionaries take more than 8% of the time, which is why reducing the sorting time can prove good results. The slide shows the results of keyword selection for different collection sizes with parallel sorting of IDF values based on the quicksort algorithm. The implementation was deployed on a system with shared memory and multi-threading platform using OpenMP. The results table shows that the proposed sorting reduces the operation time of the synthetic level of the proposed model, but still takes a significant time. It is apparent that for small amounts of data, the acceleration is almost absent. For large amounts, however, the acceleration is almost 3 times. The results of keyword selection for different collection sizes with parallel sorting of IDF values based on the least significant digit algorithm and the radix sort calculations are shown in the table. Implementation was deployed on a system with mass parallelism. As the table shows, the radix performs poorly on small sets with less than a couple hundreds of elements, and that it is the preferred sorting algorithm for high-speed applications for use in the system with mass parallelism, such as GPUs. The computation resource of NVIDIA GeForce GT 650M graphic processor with Kepler's architecture and the maximum number of 384 CUDA cores were used for the calculations. Analyzing the previous tables, it becomes apparent that the proposed term weight sorting on mass parallelism systems in the constructed frequency dictionary reduces the operating time of the synthetic level of the proposed model by almost 18%. Meanwhile, small amounts of data showed almost no acceleration. For large amounts, however, the acceleration is almost 100 times compared to the sequential sort, which is used by default. In conclusion, in the course of research, information object storage model with modified and improved methods of accelerated text processing was proposed. The detailed conclusions are shown on the slide. Further potential development will include developing the proposed model and expanding the functionality. Thank you very much for your attention.